Like x is just a placeholder. So what this function says is that f of anything is equal to 9 minus 2 times whatever that thing is. Like the x has really nothing to do with the definition of the function, and that's where people seem to get hung up as far as evaluating it for different inputs, is kind of being attached to like the x in the definition of a function. But the x is just a placeholder, like so that we don't have to write like input every single time that we want to talk about the input. All this function really says is that f of anything is just 9 minus 2 times that thing. So if I write this like twice, f of something equals 9 minus 2 times something, then every time we evaluate the difference quotient, you need to write it once. You don't have to write it in every single step, but you do need to write it in the first step. If you have to write, if you get to the bottom and you feel like you need to write the left side of the equation, then it has to be this. Like we're not finding f of x. We already know f of x. It's not equal to x. It's not equal to f of x. It's not equal to 0. The only thing it's equal to is that big fraction. So if you write the left side in every step, you have to write that whole thing. You can't write anything else. And then equals, and then we're just going to substitute. So if I see this symbol right here, I say, okay, I can make the left side of this look like that if I put an x plus h right here. And if I put an x plus h in that set of parentheses, I have to put an x plus h in every set of parentheses on the right side. So I get that. If I want to figure out what this is, I say, okay, to make the left side look like that, I have to put an x in the parentheses. And if I put an x in the parentheses on the left, I have to put an x in the parentheses on the right. So now we're just replacing. So we use the big set of brackets. Well, f of x plus h is equal to this. So where I see f of x plus h, I can replace it with what's on the right side of that equation. And then f of x is equal to this. So where I see an f of x, I can replace the symbol f of x with 9 minus 2x. And then it's all over h. So then from here, it's really just a matter of going through really carefully and thinking about if you can drop parentheses or if you have to do an operation in order to get rid of them. So I see this set of brackets first. There's nothing to the left, so there's no operations going on outside that I have to bring in order to get rid of those brackets, right? There's nothing that I have to distribute. It's not raised to any exponent. And so those square brackets, that first set of square brackets, I can just drop. And then, so I have 9 minus, and then this set of parentheses, there's a -2 out front, so that has to be distributed in order to get rid of that set of parentheses. And that's the only operation I have to worry about. So 2x minus 2h. Then I'm on to this set of brackets. And again, there's a negative in front of them, so I have to distribute the negative in order to get rid of those brackets. So minus 9 plus 2x. And then we talked yesterday about how at this point, in the numerator, everything that doesn't contain an h should add to 0. And so this is a place where you can check to make sure you didn't make sign errors. So just because you know it should add to 0 doesn't mean you should just go through and like slash it off without actually checking, because this is your opportunity to make sure it works out the way that you know it should work out, which means you can catch sign errors if it doesn't, right? If I have negative 2x and another negative 2x, which adds to negative 4x, then I know I made a mistake and I can go back and find my sign error. If you just start slashing stuff out because you know that's what's supposed to happen, then you miss that opportunity to check if you made a mistake distributing or anything like that. So we go through piece by piece, and 9 minus 9 is in fact 0. Negative 2x plus 2x is in fact 0. That tells me that I probably didn't make any sign errors. And then we're just left with negative 2h over h. And again, this is another place where you can catch mistakes if you carefully check that, in fact, that h does cancel. I mean, in this one, it's fairly obvious because there's not multiple terms, but the h cancels and we end up with negative 2. So there's, equals. There's a lot of opportunities because of the way we know this is supposed to work out. There's a lot of opportunities to catch kind of common mistakes that people make with signs and distributing. So if you're really careful in each of those steps to make sure that it works out the way that you know it should work out, then you can catch those mistakes if you made any, and kind of go back and be like, oh, I should have had parentheses here, or I should have distributed. So let me give you guys one to try. I'm going to do some copying and pasting just because my hands are not cooperating with me very much today. Copy. So we're going to find the difference quotient. And again, we will give you that on the test, so you don't have to like memorize this formula or anything. The test will say something like find and simplify, or evaluate and simplify, and then give you that fraction. So you don't have to like memorize it. Let's do f of x equals 3x minus x squared. Try that one. I'm going to look real quick at your homework so I can give that back to you today so you can do corrections. So again, you want to write this in the first step of every problem. And so again, if it helps to like write what f of x and f of x plus h are over on the side first, you can do that. So like, just like we did in the last example, wrote way too big, but if we have f of x, so f of whatever equals 3 times whatever minus whatever squared. So if I want f of x plus h, I get 3 times x plus h minus x plus h squared. Sorry, that's a little smushed in there. And again, f of whatever equals 3 times whatever minus whatever squared. So if I want f of x, then we have 3 times x minus x squared. And so then we're just substituting. So where I see f of x plus h, I'm going to put what's on the right side of that first line. So 3 times x plus h minus x plus h squared. And then if I want f of x, I'm just going to replace that with what's on the right side of that second line. Again, in brackets, so 3x minus x squared over h. One thing I'll just mention, because I'm highlighting them right now, is if with my highlighter I went like this in your first step, it's because you didn't write the expression. So just so you know what that means when you see it. I usually also highlighted this at the top. That's what that means, is if you don't, so you just need to write it one time. Just like I did here. And then you can work down the page. But again, like what you end up with isn't equal to x or to f of x. So the only thing you can have on the left side is that whole expression. So then this one, when we go through and distribute, again, there's nothing to the left of these brackets, so we can just drop that set of square brackets. This set of parentheses, I have to distribute the 3 in order to get rid of it. So I have 3x plus 3h. And then this one's a little tricky because there's, oh, go ahead.
I was going to ask if it's possible to cancel out that 3x plus h with the squared negative x plus h.
So remember, you can only combine like terms. So just like 3x minus x squared can't be simplified, the same is true here. Like 3 times something minus something squared, they're not like terms because one of them's squared and one of them's not. And so they can't be combined. So we really have to expand all of this in order to simplify it. When we get to that second set of parentheses here, notice that there are 2 operations going on that have to be like distributed, so to speak, right? I have the exponent, so I have to do x plus h times x plus h, but that doesn't take care of the subtraction, which also needs to be distributed. So we say minus, and we do exponents first. So when you square that, you get x squared plus 2xh plus h squared. So just do x plus h times x plus h for as long as you need to, but you'll do this so many times that you'll just kind of memorize what x plus h squared is. That x squared plus 2xh plus h squared. But that still has to be in parentheses because we haven't taken care of the minus sign yet. And then this one, we have subtraction in front of that set of brackets. And so we need to distribute that. If you made the mistake of not putting parentheses there, don't just go through right now and like change the signs. Make sure that you write the step where you put the parentheses, because that way when you look back, like you know why the signs changed. The important thing here isn't that you get the right answer to this example, it's that you know how we got to the right answer so that you can reproduce it. So make sure that you're writing those 2 steps where you do the x plus h squared, put parentheses around it, and then distribute. That way when you look back, you know where all the signs came from. So now we'll distribute that negative. So we have 3x plus 3h. This changes the sign of all the terms inside the parentheses. And then everything else, I already got rid of the brackets, so that's just staying the same. All over h. And then again, we're going to go through really deliberately and make sure that everything that we know should add to 0 actually adds to 0. So, whoa. So that's every term that doesn't have an h in it. So 3x minus 3x is in fact 0. Negative x squared plus x squared is in fact 0, and there aren't any other like terms. But what's left, 3h has an h in it, 2xh has an h in it, and h squared has an h in it. So all the terms that didn't have a factor of h ended up adding to 0, which is what we wanted. And then here, remember, there's 2 ways you can do this. You can think of this as a whole polynomial and factor the GCF out. Right, so we have a GCF of h over h, and then that h cancels, and we get 3 minus 2x minus h. Or you can just think of it as like division. So like divide each term by h, right? So 3h divided by h is 3. 2xh divided by h is 2x, and h squared divided by h is h. So you can think of it either way, like dividing every term by your denominator or factoring that out as a GCF. So questions on this one? Okay, let's do another one. This is one of those things, like I said yesterday, this is like the basis for calculus, this expression. So this is not one of those things, if you're not getting it, where you want to just be like, oh, I'll wait till she moves on to something else, maybe I'll get that. This is important that you're able to do, so when you get to calculus, you're still able to do it. So if you're not getting it, keep on practicing. Yes?
Would you like to go last night for a little bit?
Sure. These can be a little tricky because they're a little bit complex, but you guys can all do this. It might take a little bit of practice. You just have to do it a few times. Yes?
The answers can have variables. That's fine.
Oh, yeah, they will. The only time you may notice as you go through it, the only time you don't end up with a variable is if it's a linear function. So like on last night's homework, those last two were linear functions. There was no exponent on the variable, and those were the ones where you got like 6 and -9. So the only ones that don't have variables in them are if you don't have an exponent on any of your variables. So if they're linear. And I mean, I'm not going to give you any crazy exponents. Like if I did x, like if I had one that had x to the third in it, it gets really, really messy to cube x plus h. So I'm not going to give you one like that at this point. Good? Okay, so let's do f of x equals 5x squared plus 2x minus 8. F of x plus h, whoops, minus f of x over h. And again, that's the only thing this can be equal to, is that whole fraction. So when we plugged in, we should have gotten 5 times x plus h squared plus 2 times x plus h minus 8, and then minus 5x squared plus 2x minus 8. And as I was walking around, all of, like this step looked really good. The only thing I saw was make sure you don't forget to put that in brackets so you can distribute the negative. And then it looks really good. I think everybody got it. This is done in like 2 steps, right? So you have to do the exponent first and then distribute the 5. So we get 5 times x squared plus 2xh plus h squared. Then we'll distribute the 2 and then distribute the negative. And again, just double check all your signs. And then we'll distribute that 5. So 5x squared plus 10xh plus 5h squared plus 2x plus 2h minus 8 minus 5x squared minus 2x plus 8. And just double check all those signs. These are kind of fun because even though like they get a bit complex, it's like super satisfying because at the end it all like simplifies really nicely. So sometimes like you can feel like you're lost in the weeds, but it all works out really nicely as long as like you check and make sure all your signs are right. So 5x squared minus 5x squared. Then we have a positive 2x minus 2x and a negative 8 plus 8. And you guys were doing a really good job of like checking to make sure that actually happened. So you can always catch it if you made a sign error. Usually, if the signs don't work out, it's because you forgot to distribute that negative or put that first step, put f of x in brackets in that first step so that you could distribute that negative. So that's always like the first thing I'd check if it doesn't work out the way you think it should, or you know it should. So 10xh plus 5h squared plus 2h. So in your final answer, everything's going to be positive. So just double check those signs.
Is it always going to be in descending order? Or
So descending order doesn't really matter here because we have multiple variables.
Okay.
So when you have multiple variables, it's kind of hard to, like those first two terms have degree 2, even though they're not like terms. So it's hard to like talk about descending order when you have multiple variables. Like usually we'll put, if we want it in like descending order, we'll put it in descending order of like one of the variables. Yeah. But in this setting, it doesn't really matter because we're not going to be able to factor like the way that we factor like a normal trinomial because of those multiple variables. So all we really care about with respect to factoring this is getting that h out, and you can pull a GCF out regardless of the order it's in. So in this setting, descending order isn't super important. So again, you guys can factor an h out, or you can just divide every term by h. Either one will give you, let's see, 10x plus 5h plus 2 over h. So we'll give you a final answer of 10x plus 5h plus 2. So, and then just like Zach and I were just talking about, like the order of those terms isn't super important. So if you had a different order, then as long as you have those terms and the signs are right, then that looks good. Any other questions on this? Do you guys feel more confident with it than maybe we did yesterday? Good. Awesome. So I'm going to hand back just a bunch of papers. I've been teaching up until like the last minute all weekend, so I haven't had a chance to give you back all your corrections. So the only one